Okay. I'm assuming I'm not actually going to see who else has joined, so let me just get started, I suppose. I was hoping this would actually have a two-way component, so I could actually speak to you guys. So, does everybody get to see my screen? We'll just do like discussion on the Gitter channel, I assume. Okay. Right. So there's a couple of questions that we started off with in the Gitter channel. Let me just get them up. I'm just gonna work through some of them and give you guys at least some answers on them. Let me just put them over to this window. There we go. So the questions were, 5 minutes on what is Seneca, Seneca in a nutshell, how to split a service into separate files, and the Seneca ecosystem, etc., etc. So let me first start off by talking a little bit about what Seneca is. Seneca, wait, hold on. Well, built to be a microservices framework, is more to do with being able to map in business logic and put them behind patterns that are, so that you're able to add patterns that would get evaluated at runtime instead of, like having code that is very explicitly written to do certain things. How it works, how it helps for microservices is by the fact that you have some form of transport independence whereby you can have services running separately. It allows you to basically build your application by stitching together all of these different patterns that get evaluated. I'm going to just start off with a simple demo here using Fuge. Just Fuge.io. There we go. So I'm just creating a folder here called demo session, and Fuge has been installed already on the system, and I'm going to use Fuge generate system, which is just going to set up some basic services for me. I do actually have this running somewhere else, but so what this is doing is there's a set of generators that generate the basic structure of a microservice system that has an API, some form of JavaScript based front end, and a couple of services that are running in parallel. Maybe we're actually lucky and npm install runs quick enough. Let's give it a second. Otherwise, I can just go into projects from demo 1 where I was running this. So as you can see here, there are a couple of services in there. Each one of these services has a couple of files in there, and then inside Fuge itself, there is a Docker Compose file that has the definitions for each of these services underneath it. I'll get back to the Docker Compose file when it comes to deploying these as microservices, which is another one of the questions that we have. So to start this off, I'm going to use the Fuge shell command and pass it in the Docker Compose YML format. Fuge itself doesn't actually use Docker Compose. It actually just uses the definition format because it seemed like a well-structured format that is used by the community and actually provides all of the things that we needed to get the functionality for Fuge. The relationship of Fuge to Docker Compose is that Docker Compose is what you use to build containers and to run containers. But if you want to run the processes locally, Fuge is the one that you're going to be using for that. So it kind of re-implements a couple of those things. So what you see here is the Fuge shell. And this side is actually finished now. Hold on, let me just hide this. So what you see here is the Fuge shell running. And this is going to give you a list of services that are defined inside the Docker Compose YML file. So we're now going to start all. And this is going to initialize all the different, okay, that's unexpected. Wait, hold on. I think I still have everything running in a different tab. No. Okay. Great. Wonder why this address is in use. Huge, all huge. Isn't this always the way that everything breaks when you actually want to show it to people? Great. Now I need to find out what's going on here. Why is something using port 20,000? Just bear with me for a second while I get this stuff up and running again. Yeah, unplanned lesson, debugging Seneca. Yeah, that's pretty much what's going to happen here. So as you can see here, it's giving me an error that the address is in use, which means I need to find out what is happening on port 20,000, I think it was. /act, connection refused. Why is it not allowing me to create something on this port? Unless, yeah. Right, that didn't work. Requires an argument. Put 20,000. Yeah, I don't know. So unless what's happening here is Vim service 1, because this actually ties into one of the things that I should probably mention. So let's just go into this again, Fuge shell. Wait. Fuge post dev. Okay. So what I discovered is that we create two files in here inside this folder, which is one of them is the compose dev and one of them is Docker compose YML. So let's actually do a diff between the two of them. So as you see here, it's the ports that ended up changing. And the reason for this is that, let's see, Fuge, Docker compose YML. So the one specifies the ports and the other one doesn't. And the one that specifies the port seems to be handing out ports that is already being used by something, maybe some other service that I have running. That would have been less of an issue probably if we were actually running it via Docker because of how it does networking. But at least we have the services up and running now. So what's happening here on localhost 2000 is this is going to set up for us a, let me just get the chat window open here. Okay, this is going to set up this little web interface for us, which is hosted inside the, let me just show you which is hosted inside the front end service, which is just a basic HTTP front end that is, serving static files and that maps the API service, which is just a basic Happy-based REST interface that just like calls the actions. So as you can see here, we're now able to call the actions and then have them be executed. I'm just gonna jump into the code here now. Let me just open a new window so we can discuss what's going on inside these services. Just a second. The CD projects near form, and I'm running from demo 1. So inside the service. So there's two functions that you end up basically that make the core of Seneca. Can everybody see what is written there? Do I need to make the font bigger? Is everything okay there? Okay, so I'm assuming not. So if we then look at the API, we can see anything. I hope that means we can see everything. Okay, so API, and the API is where the actions are used. So API and services over here. So this is where you define all of your actions. And your actions are what is going to be matched on parameters. So one of the things here is that you can use more than just an object. You can also use a JSONic string, which is a very useful and quite nice simplified way of defining these, which allows you to define those as strings. And those are actually exactly the same as the other way around. So as you see here, inside the Seneca handler here, we have defined a, let's get this here. We have defined an HTTP endpoint called service1 action1 that calls this action, which is defined here as service1 action1, and it's going to basically trigger that. So if we were to now go and click here again, that's the code that's going to be called. So if we want to, inside this, basically make it export something else, I'm also going to make that export something else. We should now see, let me just see, did this help? Know if this is watching by default. So yeah, this should basically, if I save here, it should restart that service. Great. So one of the things that Fuge does for you is it takes the place of something like no daemon or I don't know, PM2, where it will allow you to actually watch for changes. So now if we do this, we can actually see that other data has been passed in. And you'll notice here that what's happening is that we're not actually restarting the individual services, or we're restarting the individual services and not the entire application. And we can do this because of the transport independence that I mentioned before. Let me just think quickly. So you'll notice here that inside this code, it is doing a seneca.listen, which by default is going to listen to an HTTP endpoint. And over here, we've actually defined when anything matches role service 1, it's going to send this over the transport, which is basically HTTP. But as I was mentioning before, the HTTP endpoint is actually also something that you can manipulate via just normal curl or REST. So we're able to curl that directly, and it's something that you can inspect and like test individual services on their own. Now, how this pattern matching works. So say that we have over here, we have another specific thing, like say, so we're going to, wait, hold on. So as you can see, I've now added more specific things to the actions or the message, but it's still only matched the most specific one, which in this case is this. So I can go and add here I can go and add here type no match and data. So this is going to not match anything, anything more specific. That type example isn't going to match. Okay, unless I make a typo and the service doesn't come up again. Isn't that always the way? Let's just see. Unexpected token legal. Okay, so this should have restarted now. And now sending. Cancel request, send. So that's still going to match that until I basically change this to match example. Here, data example. So let's see here. So as you can see, it matches the most specific one, and you can have as many things in there as you want, and it'll match the most specific one. There's actually very, very specific rules about how this matches, and it's all defined in this module, which you can read about more. Like this is the actual pattern matching that is extracted here. And there's a couple of useful things that you can do in there as well. So you can do like wildcard matching. So say, for instance, I wanted to have it so that inside this pattern matching over here, I wanted to match for anything that has a type. And then inside Postman, like if I were to send, it would send data example, but if I were to not include that, it would return the original thing. So it allows you to take patterns and stitch them together via transports, which will then get answered via, whatever you send it through. So how to split up services into separate files. One of the ways to do so is the way that I just explained, which is to have them running as separate processes. Before you reach that point, you might actually want to be in a place where you're running basically the services as a single system. In which case, the best way to do it is to have the services written as plugins. So if I just look here, let's actually create a new service here. Sorry, I'm just thinking about the best way to demonstrate this. Yeah, so if we look at how one of these services are written, so let's just see one of these plugins. So say we look at I'm just trying to find the simplest possible one to show you guys here. So I'm going to say Seneca Elasticsearch because, wait, no, hold on. Let's do NodeZoo. If you guys haven't seen NodeZoo before, NodeZoo is an example system that we're building using this technology. The features that I'm describing here with Fuge and how Fuge runs as separate processes is actually, used inside NodeZoo. You can see here are all the different services that we're running. It also uses a couple of more advanced features of Fuge to allow you to, configure things at runtime and so forth. But let's look at one of the services here. This is the microservice that responds to basically GitHub. So as you will see, there is two files in here. Firstly, there's this lib, which is the github.js, which defines a Seneca plugin. This is the format that Seneca plugins always take. You end up having a module that exports, which var Seneca this, and then it returns the name of the plugin, and then inside the plugin it defines all of its functions. Now, what this gets you is, unlike in this previous example that we had, where it was listening in the same file, this would allow you to do this. So say we go here and we basically change this from service1 to plugin.js, and we just move the Seneca stuff over here. And we basically turn it into module.exports equals function options, and var this of Seneca equals this. Return and so that is now var Seneca equals this, and now instead of having this in here, we basically end up with var Seneca.use require plugin.js. Okay, so as you notice now, this isn't listening to anything anymore, and this is now separate. So let's just see if that's restarted okay. Okay, so hopefully this will still be answering to our requests. Right. So now I've rewritten this to basically be a plugin and a service that is being executed. what this allows me to do is this allows me to create different instances of this plugin and reuse it in services. And that's basically the principle of how most of the extendability in Seneca is built. This is the pattern that you will follow, like you'll see followed just about by every major plugin, like Seneca Auth and so forth. They're all written using the plugin API, which just defines a set of actions that get triggered by the acts or the act calls inside your code. Let's just get back to the questions before I run out of roadmap. So in here, how to split up services in separate files. You basically turn them into plugins, which allows you to instance them inside your code in services, but it also allows you to reuse them inside a single service. So over here, instead of doing Seneca client, we could also have gone basically seneca.use, although I probably wouldn't have done in this file. Hold on. API index.js. So in here, I could have done, where is Seneca defined? Sorry, I'm used to working on a much larger screen. This is being added in by, so it's Seneca. I don't even know where Seneca is being instanced here. So yeah, so I instead of this, I could then have gone. I should then have been able to go seneca.use require theoretically, like this might not work. Let's see if it dies. Okay, it's listening. So theoretically, this should now start up. There. Okay, so that no longer is listening via. That's no longer listening via the client side stuff, but it's now listening via the. Basically, it's doing it directly against the service, which also means that we should be able to stop service 1 and PS. So service 1 is no longer running, which means that it's no longer running on that port, which means that shouldn't be working anymore, which now means we've basically wired up directly the actions inside the same process, which is also, it's going to break the service discovery, like the entire process of the watcher, which is restarting the services. So we have that limitation now, but that's basically how you split your system up into multiple files. You define them as plugins, and then you can load the plugins into services. So let's just revert these changes. Although I'm not going to touch on it right now, there are multiple different transports that you can use for this, which have different properties. One of the limitations that you can see here is that there's an issue of service discovery. By using an HTTP transport, we need to know the port numbers and the IP addresses of all of the different services that are basically need to be run in the system. One of the ways to work around that, which you guys have already seen, is the Seneca Mesh client, which has been used like in Node-Zoo. You can actually see how that's configured there. Other options would be something like the Seneca Redis transport, or any other kind of transport which uses a queue or something similar. So this would basically create a single point where, like, you only have to send everything to Redis, and then your server only needs to know about your services only need to know about Redis to read the actions that are executed off of there. So the Seneca ecosystems. So this is something that we've been working on like significantly for the last like 2 or 3 weeks. One of the things that I've mentioned before is that we have a lot of Seneca plugins, right? And the issue that we have is that with 258 plugins published to NPM, whenever we make a change, it's currently impossible for us to figure out what's going on inside the different packages, like where we break things and that kind of stuff. So it kind of limited the amount of changes that we can safely make to Seneca. And I think you guys are all kind of bearing the brunt of one of the first breaking changes we've made, which was splitting Seneca entity out into a separate plugin. I'm going to avoid talking about Seneca entity because it really is a system all on its own. And I'll discuss how Seneca entity works, but I'm not going to be doing any examples of Seneca entities in this little talk. So let's just start there. So the thing that we've been doing is we have all of these extensions, and we needed to basically figure out which ones of them are useful to people and which ones are actually being used and which ones are need to be maintained, which ones we can't break, which ones, etc., etc. So some of you might have seen this document, which is where we basically asked for feedback from the community about which packages are actually being used. And the other thing that we've been doing is going through our internal projects to find out what's going on there. And so we built this Trello board, which is still private. We're basically just using this as a way to figure out what is useful and what isn't. And we've been going through each and every plugin individually to find out which ones are considered, golden circle, i.e. we can't release a new Seneca version without this being ported. And then over here is, different dependencies of these packages. And then anything that was mentioned by the community that we know is used on client projects, we basically added in here. Concorda, for people who don't know, is the authentication stack that we're busy building, which is a separate authentication silo that you can actually deploy by adding directly into your Nodezoo or your Fuge configuration. If you just look at Nodezoo system, the idea is that you can add Concorda to your system by just adding it into here and deploying it alongside these services. But Concorda is where all of the different stuff is going to go into. And then this is the third-party stuff that isn't maintained by the Seneca community, the Seneca organization. And then what we're going to be doing with everything that doesn't actually fit into the stuff that is actually currently used, we're going to create a new Seneca Attic, which is a new organization, and we're going to be submitting pull requests to each one of these repositories that basically says, answer it to give it over to the Seneca Attic user, which is just an organization that everything's going to be sitting in. And it's going to have a message at the top that says, this is no longer maintained, and this is the current status of this project. It doesn't mean that the stuff that goes in there is just going to die. It just means that it's it's open for adoption, basically. So if there's anything that you guys really feel should still be in the community that you're actually using, we just need that feedback so that we can make sure that we don't deprecate stuff that isn't currently being used. The goal here is specifically to reduce the amount of stuff that we have to maintain, but also to increase the benefit for all of the all of our users, so that they can use like, you know, plugins that are actually maintained, so that you guys don't end up running into weird bugs from stuff that was written 4 years ago that hasn't ever been updated or ever been used in a live project. Anyway, that's basically what's going on here. I think that we've covered all of these suggestions. Specifically, how to get up and running with small microservice architecture. I think that Fuge is a very good way to start there. I'm not going to deal with Seneca Entity, but I do want to show you guys a little bit about what Seneca entities are. So if we just quickly look here, no, I'll just want to see if the documentation is in here, or if it's still in the Seneca.js repo. So inside the docs. So Seneca entities are basically a set of patterns that are predefined that have multiple different implementations of it. So in here, you basically, like, you know, role entity, command load, command save, command list, command remove. And then over here is like, you know, the name-based zone, like how you actually define the entities. So the way that I showed you here is the way that these entities are defined, these actions are defined. That's the same thing that Seneca entities are, except it kind of, you know, predefines all of these things for you. So when you write a Seneca store, you basically end up writing different implementations for these that save to different databases. But if you're busy, you know, writing these actions yourself that are like abstracted from your business logic, you can actually just, you know, save to the database directly. You don't have to go through Seneca entities to be able to, you know, have persistence, to be able to do whatever. Like, it does save you some time, but some of the complexity comes in, you know, much later when the system has been running for a while. So Seneca entities are now an optional part of Seneca because there's a lot that comes with them. So we've made it so that you can use Seneca entities in any of your systems by just adding in Seneca.use entity and basically npm installing Seneca entities. That's the big breaking change in Seneca 2.0. Seneca entities, well, none of this is database persistence, so I'm not going to deal with that too much right now. But yeah, Seneca entities are a topic all on their own, and it kind of, until you know how actions are evaluated, it isn't that useful to talk about Seneca entities because you're never going to be able to debug them, really, until you know how actions work. So develop user management with Seneca auth, etc., etc. This is out of scope for this presentation because of the fact that there's, you know, an entire set of like plugins that are built around this. It's actually what Concorda is about, and you guys should speak to Mircea about that if you want to know more about how they work. And then how to use Docker to deploy microservices. So I'm just going to touch on this like briefly because of, you know, the Fuge connection to this. But if you noticed how we were using the Fuge, basically the Fuge config. So I'm just going to start this up. This is going to just start at my local thing. So Docker is a very, very large topic that, you know, deserves many screencasts and, you know, handbooks and documentation of its own. But I'm just going to hopefully show you guys how to use Docker Compose to start these things up. One of the things that you should notice here is I'm using Docker Machine. Docker Machine is a cool tool from the Docker people, which allows you to, set up virtual machines or like virtual servers on either AWS or any kind of thing like that. And it basically, because the client is written in a way that is distributed. Hold on. I'm just going to Docker and just Docker PS script. Yeah, I'm actually using Bork to do stuff with Docker. That's not my favorite thing in the world. Docker RM. Okay. Yeah, that should stop all the containers. So now if I were to go in here and I basically go Docker compose -f fuge Docker compose.yml and build. This is going to go into each one of those because we use the same Docker compose format and, build Docker images for them, which is, going to go into each one of them and do an npm install, do like all of the stuff, and then ends up with a set of Docker images. Let me see if Node 2 is actually working. It's been a few weeks since I've actually built Node 2, so system Docker compose, and then I can run Docker compose up, and then fuge system.yml. So that's basically like by doing Docker compose up, it's going to pull these things up. Now, one of the things that's kind of one of the things that's useful about this is the same way that you can deploy with Docker Compose to a local virtual machine or to your local system. You can actually set up Docker Compose to work against AWS. Wait, why is this not running? Docker Compose. Okay, so that's bringing up all of those services again. So yeah, so like my internet is going to be far too slow to show you how this runs in real time, but you basically just use the same compose file that you were using to drive Fuge, and then you run stuff from there. So yeah, tons of example projects. So documentation. One of the reasons that I'm having this little chat with you guys is that we basically discovered that a lot of the documentation that we have is just, academic, abstract, and just not very useful. The big one that we found was, I think Kevin actually ran into this, was the entire getting started repo, which in my mind, has like, I don't know, like 11 math.js files, which really doesn't really prepare you for the kind of stuff that you end up doing in a real project. And let's be honest, like 99% of real projects are, basically going to be about CRUD. And because of Seneca entity, like, when you start this, it basically goes, use Seneca entity instead of showing you a basic CRUD example. So we're currently working on fixing that. But we also have the problem that we suffer from the curse of knowledge, which means that once you know something, it's very difficult to understand what people don't know, and like how to bridge that gap. So we have someone in our team working on new getting started documentation, and we're actually, for our next release, for our June release, we're really going to focus on bringing the documentation in line. But it's going to be incredibly useful to us to have someone actually, sanity check the documentation that we write, because unless there's someone actually trying to use it, we're going to have, a lot of problems, like figuring out what's going on. Yeah, let me just see what's like in this documentation. Right, so one of the questions that Kevin had here is, now I see that one message invokes one function, the pattern's unique. Yeah, so that's really one of the current limitations of Seneca. And this is something that you don't usually run into in the first week that you use Seneca, but it always becomes an issue later on. Basically, Seneca, as I've mentioned in here, is basically always going to load a specific function. But the problem is that there's no way to really do, have multiple functions executed, unless you start doing something like Seneca Balance Client. And in that case, what we're using Seneca Balance Client for is, instead of just emitting the message to just the one client that's connected to it, it will emit the message to all of the clients instead of just one. There's specific limitations that you have there. Like, you can see how that's actually being done in Seneca, in the Node.zoo repo, where we're using Seneca Mesh and Seneca Balance Client. But in general, there's a limitation in Seneca that, there is no such thing as pub/sub. So I don't really have an answer for you guys about that, other than, it doesn't really work that way in Seneca. But there are, workarounds that are out of scope for this talk. So yeah, so that's pretty much all of these resolved, I think. Are there any other questions that you guys have to answer that I can answer for you guys? Just ping me in the GitHub channel. I'll leave this open for another 5 or so minutes. Any questions? Okay, well, I think I'm pretty parched now, so I'm going to stop the broadcast, and I hope that helped people out. Do I have a solution for relational databases and microservices? Well, so Wardemir is already using Seneca entity, which has a whole bunch of drivers. So let's just go to Seneca entities. So this is already using Seneca entity, which is also in the project. They're using this Seneca Postgres store, which basically, as I mentioned, maps the Seneca entities onto the. You mean for joining? Do I have a solution for relational databases and microservices? Oh, well, yeah. So I assume you mean the fact that Seneca Postgres store doesn't join columns. So I have a couple of things that I wrote that worked around the fact that So the limitation of not being able to join is not a limitation of microservices, and it's not a limitation of Seneca. It's a limitation of Seneca entities. And like this is one of the reasons why I don't recommend Seneca entities myself. I have a couple of things that I wrote. So the first thing I did was I wrote a Seneca next store, right? And Next is basically a database abstraction layer that's a query builder based on the same one that that is used by is the same one that is used by the, what do you call it? By Laravel. It supported the Laravel one, which allows you to basically write some JavaScript, which is a representation of the query, right? And so what I did was, for another project, is I wrote the Seneca Next store, which is a non-traditional Seneca entity store that allows you to write all of the queries manually. And for this project, we basically started off in a system where it was already using the Seneca Postgres store, but it wasn't able to use any kind of it wasn't able to do any kind of joins and stuff. And we specifically wanted to do joins because we needed to introduce a more stringent access control layer, which really requires you to be able to modify the query. So we needed direct access to the queries. We needed to be able to write them. And so what we did is we wrote this entire system, which allows you to define, where is it? Hold on, not in here. So it defines entities, each is their own file, and you end up with a set of 5 functions, which are 5 queries that you write explicitly that conforms to the Seneca entity store. So what it allows you to do is it allows you to create your own Seneca entity store that you swap out the queries that are used underneath, instead of using the automatically generated stuff from how Seneca entities are done. So it kind of short circuits all of the query generation and gives you direct access to what's going on in there. The other thing that you can do is the Seneca entity stores have a native property, although it isn't universally supported. And this native property allows you to basically get access directly to the driver, right? So the driver basically allows you to do a query against MySQL. You get the MySQL connection object, and you can do the db.sql, and you can actually write your own queries, which honestly is something that it boggles my mind that people go to the levels they do to avoid writing a single line of SQL. I mean, if you just see the size of some ORM solutions that just trying to avoid writing the code directly, it's mind-boggling. So if you have code that requires you to write the join, I would just write the SQL. One of the things that I also built that I haven't actually been able to run out in a project yet is this thing called the Seneca Massive Store, which is an implementation of or basically I swapped out Next in this for Massive.js, which is this really, really cool library that is kind of like a non-ORM for PostgreSQL, which for the project I used Nextdoor on wasn't applicable because of the fact that it needed to also use MySQL, so it needed multiple databases. But what this allows you to do is this allows you to create a file that is just in your scripts folder, it's just some file.sql, and in this case it would be products in stock.sql, which is templated. So this would then go and pull in that as a function, And then inside massive.js, you could just use these functions directly. It also has a small, when it starts up, it scans in all of your database tables. So it basically creates a very similar to the entity API, and it allows you to basically use the databases as document stores. It has full text search, and it also has JSON-B documents, which means that you can use it for just about the same kind of stuff that you would have done with MongoDB or otherwise. I highly recommend using massive.js. Yeah, that's basically where that is. There's lots of options there. The best way is really to just write your own SQL. Just try not to avoid it, because when you try to avoid it, you just build a lot of code that ends up not being that, not being flexible enough in the end, because SQL is already the best kind of thing that you can use to do that. Does that answer your question? Okay. Are there any other questions? Because otherwise I'm going to end this call. And Wouldemir, one of the useful things about the Seneca entity stores is that you can define an entity store per entity. So the way that I was doing the next store is I basically swapped out each of the individual entities one by one until I'd migrated the entire system over to custom written SQL queries. You could do that with other things as well. It's a very useful feature of the entity system, to be able to not have to use the same store for everything. And it's used in a couple of different places as well. For instance, if you have user sessions that you want to store in Redis, or if you have specific things that you need to store in specific ways, that's one of the things you can do there. Okay, so I'm going to end this. I hope this has been helpful. Like I mentioned, the real solution here is to have better documentation. So as we prepare a bit better documentation, I hope that you guys will give us feedback on it, and that we can, iterate on that. And anyway, thanks for using Seneca, and I hope this was helpful. Cheers.